All right, next question up, and we're going to read the question sentence to begin. And it says, what was her descent rate? All right, there we are. So we're looking for a rate, everybody. We always want to just pinpoint what the goal is. And if we look at the answer choices, yeah, all of them are rates, feet per hour. So with that, that's what I'm looking for, my rate specifically in feet per hour. And if I am looking at this correctly, this is indeed a distance, rate, time question. We have a distance there, we have a rate here, we have a time there, we have a descending for this amount of time, another distance. So when you take a look at all of that together, you're definitely going to think that there's a little bit of work to do because we have a couple of different multiple units here. So we want to take this slow. So here's what we're going to do. If I'm trying to find the rate of descent, this is where I'm going to start to be consistent. Again, if I am looking for the rate of descent, I need to incorporate a formula that uses the distance that we descended at and the time for which we descended. One more time, everybody. It's really way too important to be consistent here. If the rate that you're looking for is for the descent, then everything needs to be about the descent. If I'm looking for the rate of descent, I need the time that we were descending at and the distance that we descended. One more time, does that make sense? Before I continue with the nuts and bolts of the problem, again, what we want to do is be consistent. We want to find the descent rate, so we'll find the descent distance and the descent time. Does that make sense? If so, then we're good to go. Watch this. So we're going to go ahead and try to find everything that has to do with the distance and time for the descent so we can find that rate. So it says a climber starts at 1,800 feet and then ascends for, at this rate for this amount of time. So again, we start off here, we go up, then we go down, and here's where we end up. And so we want to find the rate for the descent. All right, cool. Here's how I'm going to do that. I'm going to start off with the 1,800 that they gave us. And then from there, we're going to ascend at 500 feet per hour for 3 hours. Everyone, help me there. If I'm traveling at 500 feet per hour for 3 hours, am I going to count that as a positive or a negative based on the keywords that we see? Yeah, that's a positive, absolutely. So we're ascending, so we will add right there. And that'll be 500 feet per hour times 3 hours. And then from there, we see that we descend. So everyone help me out there. Descending means we do what again? We'll subtract, absolutely. So when we see the word descend, that means that we'll subtract. Let's grab blue here. At an unknown rate for 2 hours. So we'll subtract that unknown rate times 2 hours. And then we end up at 2,400. Okay, so this seems like a long, convoluted way of just saying we got to find that gap. And here's exactly how we'll do it. 500 times 3 is going to be 1,500. So 1,800 plus 1,500, that's going to give us 3,300. So now we have 3,300 minus that distance that we descended, and that leaves us at 2,400. We can actually find what that gap is. We can find that right now. Everyone, what do I need to subtract from 33 to get down to 24? What do I subtract to get there? Yeah, that's going to be 900. If you do some subtraction there, you'll see it nice and clear. If we have 3,300 minus 2,400, that leaves us with a gap of 900. So that's what belongs in here. This is the distance that we descended. We descended right here, 900 feet. And now that we know the distance that we descended, guess what we can do? Let me show you nice and easy. Let me just take this out of the way, move it down a little bit, and I'll show you right now. The distance that we descended was 900. The rate, that's what we're looking for. Everyone, how much time did we spend descending? Yeah, we spent 2 hours descending. We spent 2 hours on that little part of the trip. So we'll add that right in there, times 2. And look, using that formula consistently is really going to be the saving grace. The distance equals rate times time, and we're representing it consistently. So one more time, the rate of descent times the time that we descended for equals the distance that we descended, and that was 900. So now we'll just divide both sides by 2, and we get the rate by itself. 2 cancels out, and everyone 900 divided by 2, that's going to give us 450. And there we are. We were descending or going down at a rate of 450 feet per hour. And that's what's going to make answer choice D the correct answer. B was a close one, but you have to divide by 2 since the 900 feet was split again across 2 hours. So hopefully that makes a little more sense there, my party people. And I hope you're ready for another one. So here we are with a new question. And the first thing that we're going to do, as always, no matter how easy or hard a question might seem, everybody, the first thing that we want to do is read that question sentence, because it's going to give you hints, sometimes more often than not. So right over here it says, what is the area of the field in square meters? Okay, sounds good. So let me highlight there. Everybody, if I had to just, wildly guess what the main thing in this red highlight, what is the main key word in that red highlight that I should circle every single time that I see it? It's going to be area. Yeah, it's going to be area right there. Because when we see that word area, that is a hyper-specific math word. That is actually a word that has a formula attached to it. And so, everybody, when I see the word area, to know what formula, I got to ask what shape. And that shape is listed right here. Square. A square field is 18 meters on a side. So the first thing I do after that is think about what that formula is. And that's going to be the area of a square. That is going to be the side multiplied by itself. Sometimes you might see it as side squared. Other times you might see it as side times side. Either way, we're going to take that side length and we are going to multiply it by itself. So right here, 18 meters on a side. We'll plug in 18 right here. And we'll plug in 18 right there. And that's it. We're going to multiply and we are all good. So we have 18 meters times 18 meters. And we'll just write this off here on the side. And here we go. 8 times 8, that's going to be 64, carry the 6. 1 times 8 is 8, carry the 6 is 14. Then we'll move down to the next row, so that way we can tackle this 1 right here. So we have 8 times 1, and 1 times 1, and we're good. Now we'll add everything up all together, and so we're going to have 4, then 4 plus 8 is 12, and then we have 3 right there. So 18 multiplied by 18 is going to be 324. And then for the purpose of talking about area, this is one thing that you really want to know for future reference, not so much in this problem, but for future reference, we are going to write the units as square meters. Only because remember, any number times itself, you can write it as that number squared. 5 times 5, 5 squared. X times x, x squared. Meters times meters, square meters. But there we are, everybody. The correct answer here is going to be answer choice B after we apply that formula correctly.